All right, this lesson reviews your triangle proofs. Then we talk about Cpctc. So just like your reference sheet, we kind of talked about Cpctc. It stands for corresponding parts of congruent triangles are congruent. A lot of symbols there. I'm a lazy writer. When are you going to use this? You use this when you're asked to prove parts are congruent. But first, you must prove the triangles are congruent, which means all sides and all angles have to be congruent. All right, 5 proofs, and we're all done for this unit. We have 2 givens, and we got to prove the 2 triangles are congruent. First statement, first given. Segment AB is congruent to segment AD, and that was given to us, and you got to mark it up. AB congruent to AD. Next given, BC is congruent to CD. That's given. Mark it up. And number freebies, what else can we mark congruent? So look at your diagram. I notice I can mark the middle piece congruent. That's your reflexive. Segment AC is congruent to segment AC, reflexive property. All right. I have enough to say that triangles are congruent. So for line 4, I'm going to say triangle ABC. Match up your angles. A matches with A, B matches with D, and C matches with C. The triangles are congruent by side, side, side. All right. Last thing is what we're trying to prove. We're trying to prove that angle BCA is congruent to triangle DCA. Now here's how this works. After I say the triangles are congruent, any remaining angles or any remaining sides I can say are congruent by Cpctc. You have to say the triangles are congruent first by one of our 4 methods or 5 methods, and then you can say any remaining sides or angles are congruent by Cpctc. This has to come first. Cpctc has to come second. Next one. 2 givens. First one says PS is parallel to QR. That's given. Mark it. PS parallel to QR. Let's use the next given. It says angle QPS is congruent to SRQ. That was given. Mark the angles. PQS is congruent to, let's see, QPS, this guy right here, is congruent to SRQ. But I'm going to use that one in a second here, so just hang on to that one. Don't look at this one yet, but we're going to use it. I'm going to say that angle PQS is congruent to angle RSQ. Those are alternate interior angles. Okay, freebies are all gone. Now as we look at your diagram to figure out what else can you mark congruence, reflexive property right in the middle there. QS is congruent to QS, reflexive property. Now I have enough info to say the 2 triangles are congruent. So I'm going to say, write down my congruency statement here, and then I'll say why for the reason number 5. So first triangle, I'll go PQS. That is congruent to P matches with R, Q goes to S, S goes to Q. They are congruent by angle, angle, side. Last statement, what we're trying to prove. Segment PQ is congruent to RS. And remember, any remaining sides or angles you need to say are congruent, you can say Cpctc only after you say the triangles are congruent. Please don't forget that. Last page. Number three, it's one given, but it really counts as two because it's the midpoint of two separate segments here. So first statement, X is midpoint of WY and VZ. That was given. So basically, X is your midpoint of this guy right here and of that one right there. So we'll say that in our next two statements here. I'm going to say WX is congruent to XY. Definition of midpoint. And the other way, Vx is congruent to XZ. Same reason, definition of midpoint. Freebies are gone. What else can you mark congruent? I notice that I can mark the vertical angles congruent. So I'll say that. I'll go angle WXV is congruent to YXZ, and those are vertical angles. I have enough info to say the two triangles are congruent, so I'm going to do that for statement 5. Triangle WXV is congruent to triangle YXZ by side, angle, side. Last statement is what we're proving. Angle XWV is congruent to angle XYZ, Cpctc, because I already proved the two triangles congruent. Any remaining angles or segments, I can say Cpctc. Number 4. Two givens. First statement, first given. JM bisects angle KJL, that's given. Let's talk about the congruent angles now. So I know that JM bisects KJL, so these two angles right here are congruent. Then we got to say that. Let's go angle KJM is congruent to LJM. Definition of angle bisector. Go on to the next given. We're given that angle JMK is congruent to JML. That was given, and then mark it up on the diagram. JMK and JML. Freebies are gone. What else can you mark congruent? Reflexive property, right in the middle. JM is congruent to JM, reflexive property. I have enough info to say the triangles are congruent. I'm going to go triangle KJM. K matches with L, J to J, M to M, and they're congruent by angle, side, angle. Last statements that we're trying to prove, JK is congruent to JL, Cpctc. I already said the triangles are congruent. Then you can say Cpctc for any remaining angles or sides. Last one. Two givens. First one, BC is parallel to EF. You can count on alternate interiors for sure. Given, mark it. BC, parallel to EF. And let's mark the alternate interiors right now. I know that angle B is going to match with F. And I can also say that angle E matches with C. So let's say that the next lines 2 and 3, let's talk about the congruence angles. Angle B matches with angle F, alternate interiors. And then angle E matches with angle C, alternate interiors as well. Go on to your next given. D is a midpoint to BF. That's given. All right, so what's congruent? It says that D is a midpoint of BF. So that means that BD is congruent to DF. We got to say that. BD is congruent to DF. Definition of midpoint. I have enough info to say the two triangles are congruent, so now we say that in line 6. Top guy, I'll go BCD B matches with F, C matches with E, and D goes to D. They are congruent by angle, angle, side. Last statement is what we're trying to prove. Segment ED is congruent to segment DC, Cpctc. Because the triangles are already congruent, any remaining sides or angles, you can use Cpctc. That's it.